Hello pre-calculus class. Today we'll be reviewing chapter 9.1, which is on the ellipse. This is the ellipse, and an ellipse looks similar to this. It's not a circle, and it has a major axis and a minor axis. Now we will go over some vocab. So the vocabulary for an ellipse: the major axis, which is the line segment that joins two vertices, which is what I said before. It's the one that goes like this, or it can go like this, depending on the way that the foci are located. And the vertices are the line through the foci that intersects the ellipse at 2 points. So if this is the two foci, then these would be the vertices, and the opposite for this one. And the minor axis goes this way with co-vertices up and down or left and right, depending on which way the ellipse is located. This is an example of a better drawn ellipse where you can see the center point is the midpoint between the two foci, which are located here and here, usually on the graph. That's what we're going to be solving for, as well as there are also co-vertices at the other positions, but opposite from the normal vertices on the x-axis.
So this is the standard form of the equation of the ellipse, and it is x squared over a squared plus y squared over b squared equals 1. And a squared and y squared can be interchangeable, but a squared is always going to be greater than b squared. So these are how you find the x and y intercepts, and to find the x-intercepts, you use x squared over a squared equals 1, and then you solve, which would give you x squared equals a squared, and then you'll get x is equal to plus or minus a. And then you do the same thing for y using y squared over b squared is equal to 1, and then you'll solve getting y squared is equal to b squared, and y will equal plus or minus b.
This is the current problem, which involves the U.S. Capitol building, which is 96 feet long and 23 feet tall. And we can use the rectangular coordinate system in the figure, which is graphed using the origin, to find the standard form of the equation. That's the first part that we'll be going over. And the second part is John Quincy Adams discovered that he could overhear the conversations of the opposing party, which are located on the left side of the chamber, if he put his desk at the focus of the right side. So we need to find the focus using the standard form of the equation of the elliptical ceiling, and we need to locate how far from the center is the focus, where is his desk. So when we're solving for part A, first we need to start off knowing the standard form of the equation, which was first reviewed, which is x squared over a squared plus y squared over b squared, and this is equal to 1. And if we put it into the equation, it's given that a is 48 and b is 23. 48 squared, it gives 2,304, while b squared, 23 squared, equals 529. And this is the equation in standard form, which is what part A asks for.
So this is the formula on how to find the foci. So we use the formula a squared plus equals b squared plus c squared, and we know that a squared is 2,304 and b squared is 529. So when you solve, you get c is equal to square root of 1,775, and so when you put that in the calculator, you'll get c is equal to 42.13. And 42.13 would be rounded to 42, so you know the distance would be 42. So the foci is 42, 0, and negative 42, 0.
So this is a visual representation of the problem. So we know the vertices are at negative 48, 0, and 48, 0. And John Adams wanted his desk at the foci of the ellipse because of its elliptical dome shape of the building. He was able to hear the opposing party, which is also located on the left-hand side. So now we know, using the equation for the foci, the distance between the center point and the foci, which is 42 feet, which is where John Adams will then place his desk.
So this is a review of the translations that were in this lesson, and the standard form for it is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And h is the translation over the x-axis, and k is the translation over the y-axis. So this concludes our lesson on chapter 9.1, the ellipse, and thanks for watching.